Hello, everyone. My name is Steve Zhang. I am a senior principal engineer at Qualtrics. And today I'm excited to share with you some of the learnings that we had as we implemented microservice architecture and improved our architecture over the last 6 years. And that's the amount of time that I've been with the company. And I feel like we've really made a difference and made great strides in terms of security, reliability, and scalability of the platform during that time. And some of the learnings that we had during that time hopefully will be interesting and useful to you, especially if you're working on software as a service product in the cloud. So before we get into the technology contents, I just wanted to quickly explain what Qualtrics does. Qualtrics is actually a software as a service platform that helps organizations to understand the experiences that they are providing to their audience, the audience being their customers and employees, right? The chances are that you haven't heard of this of our company Qualtrics because our customers are enterprises, right? So we work with Fortune 500 enterprises to help them go out and collect human experience data via multiple channels. So you might observe some of the chat interactions that the employees are having with the customers, or even the recordings of support calls. And using natural language processing and machine learning techniques, you can actually turn these into data that can be aggregated and analyzed so that you can, in aggregate, understand what the important issues are that the customers and employees are experiencing, and what the trend is in terms of satisfaction level and engagement level. And then Qualtrics helps these enterprises to come up with action plans and integrated actions and automation to actually improve these experiences. And this is a huge part of running the company successfully and providing the best experience possible to everyone involved. So this is the new category called experience management that Qualtrics really pioneered, and that's what the company does. So in terms of scale, there's about 1,000 different moving parts in a given data center. We have data centers around the world, and it's a very symmetric architecture in every data center that's deployed, but each data center can be fairly complex because of the broad surface area that we need to support. And when I talk about microservice, we actually have like almost 1,000 different moving parts that we need to manage and maintain in these data centers. We have about 100 teams at this point, and we have over 13,000 customers worldwide. Again, these are enterprise customers, and we store billions of profiles and transaction records and events that we detect from these events and experience data that we collect, which turn into automated integration with existing IT systems. So it might be interesting to talk briefly about a little bit of history behind the architecture and the work that we were doing in the last 6 years. Qualtrics started, like many other companies, started as a pretty typical 3-tier web architecture, also referred to as LAMP stack sometimes, because Linux, Apache, and MySQL and PHP were very successful and popular combination of technologies that people used. But these architectures used to produce fairly monolithic applications. You would put a lot of code in the PHP that implements the application logic and store data in MySQL. So as the company grew, I think just like many other companies, Qualtrics started scaling out the data layer by sharding MySQL, but fundamentally, MySQL is not designed to be a technology that that would horizontally scale. So over time, we've actually migrated our data into database technologies that you can scale horizontally with, say hundreds of nodes that support fairly high cardinality of data. We use DynamoDB for that. But along with that, we've containerized all of our functionality. So at this point, all of our microservices, workers, and database, even the databases are all containerized. And then we use container orchestrations for some of them. Not all of them are within container orchestration, but many of our microservices are now running on top of a framework called Nomad, which is a simple container orchestration framework. So we've reached fairly good state in terms of microservice architecture. And today, what I'd like to talk about are some of the architecture patterns that emerged in this process of getting there, as well as some of the engineering patterns, policies and processes and cultures that we built over this period of time to support scaling out the engineering team and the platform. We will also talk about some mistakes that we made along the way in the hope that you know about them and you can avoid them for yourselves. So going into some architecture patterns that I'd like to talk about. So overall, one of the things that we embraced is multi-paradigm architecture, meaning we have a fairly broad surface area. As you can imagine, we need to go out and collect human experience data via multiple channels. And then we need to ingest them through a scalable data pipeline. And those data pipelines will feed the data into the analytics engine. And analytics platform will support business intelligence like user interface and turn into actions and tickets and all these transactional systems that exist in our platform. So it's a fairly broad surface area, and we've employed different types of technology stacks to support each functionality in this platform. So let's talk about some of the architecture patterns that emerged during the time that we were improving our architecture and moving more towards the microservice architecture. So I think at the high level, the first thing that I would point out is that, for a broad system like Qualtrics platform, we really embraced multi-paradigm and distributed architecture. What do we mean by that? So as you can imagine, Qualtrics platform has a fairly broad surface area. So we need to go out and collect human experience data through multiple channels. We need to ingest them through our data pipeline, put them into our BI platform so that they can be analyzed and presented in a BI-like user interface to the business users. And then also the insights that are generated get delivered into our low-code, no-code platform that performs workflows and actions. So as you can imagine, this is a fairly multifaceted platform and high scaled out broad platform. And in this kind of case, in this situation, you really can't think about building all this using just the same technology stack. So you will see that there's many different patterns that we use for different parts of this overall platform architecture. So the first pattern that I wanted to talk to you about is the spoke and hub model. As you can imagine, we have to do a lot of interactions with the end users or the audience, the customers or employees that may be distributed around the world for a given enterprise. So what we do with Spoke is that all the functionality that are required in this uh, interactive data collection are put into these component of the architecture called spokes, and they are distributed around the world. And as the user starts to give feedback, the GeoDNS mechanism will direct them to the closest data center to the end user. And we collect the information from around the world this way. But when it comes to aggregate data analytics, all the data that we collect have to now come to a single data center so that the business users can analyze them. And that's what we call the hub. The hub data center contains all the analytics data and all the mechanisms to analyze the data and produce insights, and we turn them into interactions that integrate with existing IT infrastructure. So that's the hub. So by segregating these two parts of our platform, we can scale them out differently or even distribute them differently from geographical perspective, and and connect them as needed to implement the overall architecture. So this was a fairly successful pattern at Qualtrics. And then, as you can imagine, ingesting data is very important at Qualtrics. So this unidirectional data flow is a concept that we enforce, and that is that all the incoming data go through exactly the same data pipeline that's been scaled out and implemented asynchronously so that it's resilient to partial failures and it's easy to scale. So that's one pattern, but there are some components in the platform that you really can't get away without having a strong transactional right semantics. So these are, we still have plenty of OLTP or online transaction processing needs within the platform. And in these cases, yes, we still use the relational databases and increasingly more DynamoDB from AWS to store some of these transactional records that we need to manage within the platform. So OLTP is still a good big part of our platform. And then we have a specific focus on making our front-end user experience responsive. We've got Elasticsearch-based, indexed data sets that provide interactive analytics experience to our business users. But at the same time, even if the analytics involves batch processing, for example, in case when the end user wants to perform some statistical analysis on a large data set, these things are background jobs that require a long-running batch processes, but the UI can still be designed with progress indicators and work and job state indicators on the front end to make it pleasant to use, even though things take longer in the background. It's just a matter of designing the user interface and user experience in such a way that things are clear to the user in terms of what's happening. The wrong thing to do would be to make asynchronous UI that's waiting for a background job. In that case, the user is just stuck waiting for this long-running job, expecting it to come back anytime without having a clear idea of what's going on. And then we are embracing a lot of the domain-driven design. So instead of expressing our interfaces and events based on technical implementation details, when we name our event, we first really think about what would be an event that would make sense to the business users. the same thing at the interface level. So by designing and thinking about in these terms, our implementation details are hidden behind these abstractions, and the architecture becomes a little more stable, and the events become a little more meaningful as you process them. For example, invalidate cache is not a very good domain event because that's totally dependent on the caching technology. Rather than that kind of event, we opt to use events like dissatisfied customer detected, right? These kind of events are very easy to understand that represent the business logic much more robustly than if you were trying to do something more just technology implementation dependent. The other very important pattern that exists in our platform is batch processing. Knowing which use cases fit batch processing can be very effective in reducing the cost and managing the customer expectations. You don't have to try to index everything just so that everything is immediate and real time. It'll bring with it additional difficulty and complication when you try to index and do everything very quickly, even if you don't need to. A lot of times we would use Parquet file formats and S3 objects instead of index databases to store things much simpler and make it much more friendly to processes that require looking at every single element anyways in the data set to perform complex batch analytics. So the final pattern is workload separation. As we saw in hub and spoke model, sometimes it makes a lot of sense to partition the architecture along the lines of the functionality and the functionality that you're trying to implement. In our case, we've separated out all the machine learning infrastructure completely from the hub data centers, and we keep them in a separate virtual private cloud, and that is tailor built for machine learning platform. So we basically have a separate platform that has a different characteristics when it comes to the kinds of hardware that we use, the kinds of data management designs that we use. And we separate these two pieces of the platform into different VPCs and manage them independently. And this has been also a fairly reasonable design and has been working pretty well. So, okay, so what are some of the mistakes that I wanted to point out? First of all, monolithic applications in this day and age becomes really hard to manage, because if you have a 1,000,000-line code base that is being released at the same time, all the teams that are interacting with the code base has to coordinate with the rest of the development team before they can ship, right? So this has been a technical debt and something that we've really broken out into smaller microservices that are managed separately, which makes your team much more agile and scalable as you scale out the engineering team. And also, this is a kind of a small point, but having homegrown deployment mechanisms almost always are much worse than adopting standard open source tools for deploying and managing your production operations. We are really investing in Spinnaker to make sure that the development teams have very consistent and well thought out deployment patterns. So this actually saves a lot of time to individual teams in terms of how to set up good deployment mechanisms, right? Whereas if you're writing, homegrown custom code, it's anybody's guess what kind of quality you will get from the deployment. And deployment is one of the very important things in software as a service when you're running it at scale. And at some point, we had this mindset of one size fits all for storage. And this was kind of a mistake. At some point, we promoted the use of HBase quite a bit across the company. And it turned into a situation where a lot of the use cases that didn't fit HBase semantics, like eventual consistency, was used in these cases and caused a lot of bugs and heartaches from the operational perspective in production. So when you're choosing technologies as storage layer, you really need to analyze your use cases and requirements and make sure that the storage provides the kinds of guarantees that you assume when you're building your technology stack. And then finally, relying on manual processes always lead to some sort of human errors, or with all the good intentions, people do forget about performing them. So automating everything really has become one of our tenets within engineering. So let's talk about some of the engineering policies and processes that we've established and used over the period of growth to maintain our velocity, as well as the culture that is conducive to enterprise SaaS company, right? I want to point out that Qualtrics engineering team grew from about 70-person engineering team 5 years ago to now about 1,000-person engineering team. So this was a fairly rapid rate of growth. And these are the engineering processes that we've used throughout this period. And of course, the first one is agile software development lifecycle. We really value quick iteration and experimentation with our software in production. And we have business owners and product managers closely interacting and collaborating with development teams in every sprint to give feedback. So, and then along with agile development, we ensure that every team has automated continuous integration and deployment mechanisms. As you scale out the software as a service company, it is very important to automate all aspects of your software development lifecycle so that manual steps are eliminated and automation can ensure reliable deployment. So we've been using a lot of Jenkins and what's called rundeck mechanisms to manage our production deployment so far. But now we are investing heavily into Spinnaker to really standardize the deployment mechanism across the board so that the developers are always getting the best practices and performing good change management for our software. And when you're performing agile development, really unit testing is key. At this point, we have 80% minimum code coverage requirement for all the new code when it comes to unit testing. I think this this requirement has gone up a little bit in the last year or so, but this is the minimum requirement, right? We have teams that really try to hit much higher code coverage levels with their code. So these 100 teams are, operating fairly independently from each other, and they release daily or weekly sometimes. But the key is that teams don't have to wait or coordinate with other teams to be able to ship their software to production. And that's actually one of the main benefits of microservice architecture. And then the other thing that was really important in a enterprise SaaS company is dedicated security operations. Having security focus is critical in enterprise SaaS. And we have a fairly large group of security operations organization that ensures vulnerability management of all our operating system images and software packages that we use in production. as well as penetration tests and static code analysis, and all these, deep security operations that we perform on our software to make sure that our customers' data are secure within our platform. That's key. And then in terms of goal setting and management of the engineering teams, we have quarterly objectives that everyone sets and works towards using OKR process. Objectives and key results is a methodology that we use to have engineering teams really focus on the goals that are aligned with the business. And then this North Star architecture process paints the vision of where we want to be in terms of architecture and the platform state in the long run. So 3 to 5 year time frame. And this company level North Star architecture trickles down to individual teams, which oftentimes have their own North Star architecture for their part. And we coordinate our architectural efforts in this way. And with all this, the other very important aspect of SaaS is, of course, operational posture. So we keep close eye on mean time to detect and to resolve when it comes to production incidents. And we really emphasize detection being automated. And whenever there is a production incident, we make sure to do root cause analysis, which turn into action items that have to be performed within a certain amount of time. So that keeps our operational posture healthy, and each team performs operational reviews, and we also even have a company level operational review where we look at key metrics across the board to make sure that we are operating with high quality. And then, lastly, we also perform something called disaster recovery game days, which simulates complete disaster scenario in one of our data centers. And we recover, of course, not with the customer data, but with the staging data. We make sure that our recovery mechanisms are functioning and healthy. Twice a year, we perform this. So what are some of the mistakes? One of the easy thing to get into is adopting open source technologies without the plans to maintain it. Earlier in our history, there were some developers who would just bring in open source technologies without any gates. And these things you can make it work, but making it work once versus having to maintain it for the next 10 years is a different matter. And whenever we bring in open source technologies today, we are now talking about how to support it permanently, because we are on the hook for the maintenance and response to any kind of failures of the technology in production. So this is something to keep in mind when you're managing engineering platform and organizations, right? And we also emphasize basic hygiene. Incorrect error codes sometimes, or sometimes lack of code coverage. These things may not seem like a big deal at the beginning, but you can slide down pretty fast if these imperfections become the norm in your code base, right? So whenever we see these little problems, we tend to really emphasize fixing them so that we don't have this broken window syndrome where a little bit of a lax standards can really slide the whole organization down from the quality perspective. And if there's one thing that really didn't work well in our experience is shared responsibility or shared ownership of code base. If there is a code base that need to be fixed, but if the ownership is unclear, then because everybody is so busy, they tend to push the pass the buck to the next person, and having a clear ownership of everything really is something that we strive towards, especially within a company like us that has a lot of legacy code bases and components that came from the past. It is very important for us to identify the clear ownership of these things and make sure that these components are maintained or retired, right? Better way to maintain it is retire them and replace them with better code that is actually current, right? So in conclusion, there's a lot of efforts that go into a multi-tenant software as a service, and I hope some of the patterns that I highlighted today will resonate with you as you're working on these things, and I'd be very happy to reply to any feedback or questions at this point. The best way to contact me is through LinkedIn. I think at the beginning of the presentation, under my introduction, there's a LinkedIn address. So feel free to contact me and I'd be happy to chat with you about anything. Thank you.